Hi everyone. So in this video, we want to look at pin to target, or you could call it a soft pin or a soft target, which is a bit more tricky to understand. And the idea is that we give the points a goal to reach, but they're not necessarily reaching it. So what does that mean? So I have a toy here and it has a simple animation on top. And if we create a normal Vellum cloth and a Vellum solver, what would happen is, as long as we have a ground plane activated, which we will quickly do, it will just fall down and of course not follow the animation. So to change that, what we can do is, well, first of all, we could just pin all the points, but then it would just stay in space and not do anything. Or we say match animation. And what we then have is the animation, but it's not simulated. So the pin to target is the idea that we kind of simulate something, but animate it at the same time to give it a certain behavior. So the easiest and quickest way of doing this is just switching the pin type in the Vellum cloth to soft. And we should see now that it has the animation, but currently there's nothing that it can react to. So the easiest way of showing what's going to happen is just give it a collision object. It would also react to forces, but then it's sometimes a bit tricky to make this visible. So this is the easiest to understand. And if we run this now, what we should be able to see is that it follows the simulation, and now already there are problems. So let's just look at the first couple of frames. So it still follows the animation, but then it reacts to anything the simulation tells it. And the problem is that works kind of, but it creates problems. Now, the first thing you should always do here is increase the sub-steps. I mean, you could increase the constraint iterations, but in my experience, increasing the sub-steps is a very efficient way of getting a result that works quickly. That will not solve the problem though. It's just kind of a necessary step anyway. What happens here is that when you set the pin type to soft on the cloth constraint, is it now turns those stiffness constraint attributes to the target stiffness. In other words, you can define with this now not the stiffness of the overall cloth, but how stiff it will try to reach the goal. And that means you have to usually lower them down a good bit. But the problem with lowering them down is that now you kind of lose the behavior of the cloth. All this node now does is it tries to follow the target. So I would actually recommend, and it's actually also very hard to get rid of this problem because you can see here it's still there even with lower numbers. What I noticed what works much better is not using the soft target directly in the cloth, but using it in combination with the cloth. So we turn this actually back to permanent, and we can actually dial all this back to defaults. And we create a new constraint on top of the cloth constraint. And we can do that with a normal Vellum constraint because there is no preset for that. There's no configure preset. And we choose here pin to target directly as a separate step, so to say, as an additional constraint. And what we have to do here is we have to basically set the same things. We have to set it to soft and match animation. And again, make sure that you turn it off in the Vellum cloth. So it's probably not working yet, but I just want to check if anything breaks. The advantage of this is basically imagine it as two things. So the first thing just creates a cloth that behaves like a cloth, and the second one is purely for making the cloth follow the target instead of doing both at the same time. And as you can see, there's still errors, and the reason is, like I said before, the settings are too high. So in the pin constraint now, what this says is how stiff the goal or the target following should be. So let's lower this. So the numbers that worked for me in the end were 0.1 and 1 and 0.1 and 1 in bend and stretch. The thing is, it's a bit fiddly to make it work, and it depends on your case. So it also, I think, could have to do with the fact that it's a relatively fast Vellum object. So play around with this, but you can see now it now works. It follows the animation, yet at the same time it reacts to its surroundings. Sometimes a bit in a weird way, as you can see here, because now it kind of really tries to reach the goal. Actually, let us show the goal. I think that makes sense. So it looks like this. And you can see the idea. It's, like I said, it's a bit tricky to find the right numbers to make this balanced and stable, but I prepared a little example here that shows you kind of a parkour for our toy here. And I just want to compare the different approaches. So the first one is, like we saw in the vellum cloth, just setting it to soft, which in my experience just by itself is very unstable and you lose a lot of control. And it's very prone to error, as you can see here. This kind of stuff, to me, happens a lot if I try to do that directly in the vellum cloth. Then, like we've seen, what works better is to have a separate pin to target, because then basically it's all about balance. What happens here is that the cloth constraint before kind of keeps the object in shape. And the pin to target tries to reach the goal. So you have two constraints that try to keep the thing in balance, let's say. So it's all about finding the right numbers to keep the thing working. But even here, sometimes like here, you get errors. And it can really go as far as something like this. So it really depends on your case, how you manage to figure out the balance between the target and all the constraints that try to keep your geometry intact. The best results I had with this so far, and we will look at this later, is when you apply a volume constraint, which means it not only creates a hull that tries to stay together, but it tries to keep the object in its volume intact. And this is something we'll look at later. In this case, I used struts. So just keep that in mind for later. And you can see here, this, in my experience, is by far the most stable way of doing this. Because again, it's not an empty hull, but a solid object that tries to keep the distance between opposite points as well, which is actually something the strut constraint is doing, which is something we'll talk about later. So this is a bit more fiddly to make it work. In general, I would recommend using a pin to target constraint directly. And it's all about not just setting those numbers, how strong it tries to reach the target angle and distance, but also all the constraints that try to keep your object intact. This kind of balance is what makes the system work, and therefore it's a bit harder to get it right. And some funny things can happen when you do it properly, and it can look really cool. Okay, so that's the first pinning concept, the soft target or a soft pinning or a pin to target constraint. And this is usually a bit more advanced, but maybe that's something exactly that you need when you want your cloth to follow an existing animation. All right, so I hope this was helpful. Thank you very much. See you later.